I'm your host, Grayson Pulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends, mobility with leaders and innovators to make it all happen. On today's episode, we're absolutely honored to be joined by Teijin Aramid's Tony Mathew and Brunel Solar Team's Martijn Boonen. On today's episode, we'll discuss how a student-built solar car just crossed 3,000 kilometers of the Australian Outback, powered only by sunlight. And yes, they won the 2025 Bridgestone World Solar Challenge. We hope you enjoy this episode. Gentlemen, welcome to the podcast.
Thank you for having us.
Thank you.
It's great. Martijn, Brunel, all you seem to do is win. You've won 8 global competitions, and it just seems that you're the Alabama football team for college of solar racing. So congratulations on that. You recently went through 3 kilometers through the middle of the Australian desert with solar as your only source of energy. Paint a picture for us. What is that like? What did you see? And how harsh was that environment truly to operate a solar vehicle in?
Yeah, so as you can imagine, 3,000 kilometers through the Australian Outback, that's not an easy feat to do something like that, especially only on solar energy. But yeah, in general, you just see a lot of nothingness, a lot of driving. But this year, I have to say, the competition was really, really intense. So we were alert all the time.
From an intensity perspective, is that because of the environment? Is that because you're in a race? Or is that because there's trucks or other vehicles on the road that you have to pay attention to?
Yeah, it's mostly a combination of all of them. This year, we had really hot days in the beginning, but we also had lots of rain at the end of the race. The competition themselves, they were really good. So we only drove like 10 kilometers apart from each other at max during the race. And of course, you have to take all the traffic into consideration as well. So that can be quite hectic at some times.
You have hot, sunny days, then you say you can have hot, rainy days. So how do you engineer the vehicle for these two different dramatic driving environments? Just from a human perspective, driving in the rain is not fun, and driving turn the air conditioning on, but you're in solar in the middle of the desert. How do you engineer for those two different environments?
Yeah, exactly. It gets really, really hot inside. What we do is we design the car as airtight as possible to make sure we don't have any aerodynamic losses. But of course, that makes it really, really hot inside for the driver. So we have a little fan implemented for him. And yeah, the rain as well, we had to take extra consideration to isolate and make all our electrical components safe, because it was the first time I think we ever encountered rain in such a race.
Oh, and so, I mean, Tony, that ties what Martijn clearly stated to me, in my humble opinion, was that the conditions were demanding. There was a lot of things that the team had to be prepared and had to engineer. And your chief commercial officer has publicly said this really great line. I'm going to quote this gentleman here. Our role is to provide materials that enable ideas to come to life, even in demanding conditions. Did you take that philosophy in mind when you worked with the Brunel Solar Team to overcome these vastly different environments and conditions?
Yes, actually, we were prepared. Actually, if you ask me, Faron or Aramids in general, actually, by the definition that it is a high performance material, we are already present in many different demanding applications. So this is not something new for us. And in this case, we are testing the Faron Next, which is the circular variant of the Aramid fiber that we have. It's an opportunity to test its performance in an actual application. And this is a wonderful opportunity for us to see how our material is behaving in such an application. And for any material company, this is actually, it's a wonderful opportunity. So we will never miss it.
What were some of the key takeaways that you took away from the circular variant from this 3,000 kilometer run?
I think that the first thing is that it works, that the sustainable aramid or the circular variant of the aramid fiber works in such a demanding application. And that is one of the first takeaway. And sustainability and performance can really go hand in hand. That is one of the key takeaway for us from this all exercise that we did together in this project.
So in your opinion, do you feel that this race validated that performance sustainability can coexist and work hand in hand together?
Yes, indeed.
And Martijn, I alluded to this earlier, but performance, wow. So the 2025 Bridgestone World Solar Cup victory was the team's 8th global competition win. So congratulations on that. It was your first win since 2017. You're back on top. How does it feel?
I mean, just amazing when you finish the race and you know that you have won, then all the emotions come loose. So a lot of happiness, a lot of tears of joy, and especially on the podium, then everyone just bursts out of energy of joy and happiness because we worked 13 months nonstop on this project and to make sure we took that trophy home. So that's just amazing.
Tony, when did Teijin Aramid start to explore a potential partnership with the solar team? When did that process start?
Teijin Aramid was working together with Bridgestone Corporation for the development of the World Solar car tire. And we were actually developing the Twaron Next, the circular variant of Aramid fiber for use in that particular tire for the belt area of the belt reinforcement. So being we as a company based in Netherlands, it was for us more a natural extension to approach Brunel Racing Team, who is also in Delft in the Netherlands. So then we approached, and there was quite a lot of enthusiasm from both sides to have such a collaboration. In the first meeting, we saw quite sort of alignment between both companies or both parties on the way of thinking, and also the lot of enthusiasm to move ahead. And for us, it is also a good opportunity to get feedback from the team, how the tire and our material behaves in such an event and such a demanding condition.
And Tony, to me, you're both in the Netherlands. It's Team Netherlands. Was there a national pride, since it's two companies based in the Netherlands that are working together to win this race? Was there some sort of national pride that emerged?
I think it is more inherent in that one. I say this, the orange color, the Dutch thing, everything. I think it's Aramid was invented in the Netherlands. So the location where I am here sitting is basically birthplace of Twaron. So this next to the next building there, the pilot plant, where it was like the first experiment where occurred. So there is indeed a certain level of pride in this activity. And of course, we basically coming with having now a Japanese mother company, I think going together with the Bridgestone, that also connects us a little bit further in that direction.
Martin, the team turns over very similar to a college football team. Sorry, you're in Europe, so American college football team. So I had to get the correction in there because you're based in the EU. How does the team have a sustained success over time? Is it the culture of leadership, or is it the philosophy when you join the program? What have been some of the keys to success over the years?
Yeah, there are a lot of things that contribute to our success. And one of those things I would say is partly, as you mentioned, philosophy and mentality. When the first team from our university started the solar car project, they needed a mentor, and they went to one of our college professors. It was Wiebe Ockels, also known as the first Dutch astronaut. And he told the team that he wanted to be involved, but only on one criteria, and that's that he wanted to win. So every decision from then on was taken to make sure that we would finish in first place during that race. And that's a mentality we have kept over the years.
Tony, so the goal's clear. You got to win. Was there did you feel any engineering pressure? Okay, so we're going to put circular content out there, and the goal is to win. It has to perform. Any pressure that you felt from an engineering perspective to meet that goal of winning?
I think there is always, when you are developing a new material, there is always let's say, a high demand there. To what is more important here is to meet the performance aspects intact, or keep that intact while developing the circular variant. Aramid as such is known as a high performance material, but while we develop the circular variant, it has to meet the same performance as that in the original variant. And that is what we have carefully looked at during the development phase. Since our materials are already used in many demanding applications, we have all the experiences in looking at how to look at these performance aspects. in the new materials. So we do all kind of accelerated testing, all kind of simulations on how the material will behave in the new in the application. And that is being done. And then we can also control to a certain extent, as we boost sustainability in the new variant, how much we can afford to change the performance aspects. Then we went to Bridgestone. Bridgestone tested it, and that is also another basically proof that, okay, this material can work under their conditions as well. And then later on, it is now proven by the race itself that the tire really performed good. So which is actually a testament for us as well.
With the circular variant, and this is a forward-looking question, looking out into the future, because you're getting all this data, you're getting all this research, and you could do a lot of really interesting engineering around the circular materials of what you can do with it. Do you see it unlocking any potential optimization in terms of better performance for longer range or lighter materials? Do you see anything being unlocked from an optimization perspective later down the line?
I think it's an evolving product series. So what we are now doing is the Tvaro Next, that is the sustainable product line that we are going to introduce into the market. And that is actually a journey that we have just begun. And within that one, we have one with actual circular content in it, and the other one with another biocircular content in it. So it is an evolution process because the whole industry is slowly taking steps in making material circular. So this is just a beginning, and we are continuously evolving into increasing the circular content and eventually make 100% circular aramid fiber into the market. So that is the journey that we are in.
Martin, on the Nuna 13, which was the final design, were there any other circular materials or elements on that solar vehicle?
In general, not that much. Sometimes when you look at certain electrical components, they are very efficient, and it's not worth it to just buy or make new ones because the performance and efficiency is just that high. But actual recyclable material are not that prominent inside of the car, unfortunately. We would want to improve that, of course, but as the product from Teijin is an exception of that, but quite some products that are high performing are mostly not circular, or they don't combine the best of both worlds. So that means that performance often goes before circularity.
When you were looking at materials to use in the vehicle, was the one thing you're looking at, obviously performance, but were you looking at weight, or what were the key ingredients that you were looking at as you designed the Nuna 13?
In general, it's an optimization of a lot of factors. You have weight, of course. You have efficiency, so you want as less rolling resistance as possible, and you want to maximize your solar income. So that's that. You have weight, income, also efficiencies of bearings, mechanical components, and electrical components, and then of course the aerodynamical efficiency as well.
And so I'm going to give the audience some stats here, because the Nuna 13 achieved a 98%, that's right, a 98% motor efficiency and weighed only 160 kilograms. That's an engineering breakthrough. In simple, non-engineering terms, how the heck did you pull it off and do it?
I mean, we know what we need to optimize, and we just engineer, keep on engineering until we're satisfied. So the mechanical team is scraping off grams of mechanical components. I myself was looking for months for the best possible solar cells, and the aerodynamics team worked tirelessly to get the most aerodynamic car as possible. So it's a lot of hours, and also help from our alumni, so previous team members.
Alumni is great. You say I'll use the term. You have great additional coaches that can help your coach go with the main goal of winning. Tony, the engineering that the Brunel team has done is fantastic. There's a lot of, I would say, commercial takeaways that you can learn, I could learn, or any industry could learn from working with that team. Were there any takeaways that you had from working with the Brunel team that you've now passed off to the commercial team inside of your company that are looking at different, perhaps engineering techniques or different ideas to explore based on what you've learned?
I think the first learning, as I mentioned, that the material with circular content works in the application. That is the first learning. I think more importantly, the second, the softer aspect of this is the working with a younger team or a young team of engineers actually gives a lot of enthusiasm, and they work much more in an agile fashion as a team than many bigger organizations work. So that is actually something to review and let's say take back in our day-to-day activities in companies. So that is a little bit, that is one of the takeaway.
Did your company have engineers embedded with the solar team working hand in hand, or did they come visit your laboratories to test things, or what did that relationship look like?
Actually, there was no such connections between the engineers, between our teams. What we did in this basically is we worked together with Bridgestone tires to develop the tire. And then the tire was basically used by the Brunel Solar racing team, and then they gave the feedback on how the whole tire performs. And we had sessions on, let's say, introducing the tire structure as such, and also to see the important aspects of there. Other than that, in the development of the car, we didn't work together for any aspects. No.
Tony, staying on the theme of tires, this is an open-ended question, but you're an expert on this. How important are materials for tires?
In the design of a tire, materials are an integral part of it. Tires, it consists of several parts. So the tread area, the under tread, the sidewall, the bead. So several components are there, and each has its own function to perform. And each component is also made from different or 20 or more different categories of materials in it. And each material has its own function to serve in that one. So it is a very important aspect from the design of a tire. You probably also realize the fact that tires typically has to meet conflicting demands. You want to have lower rolling resistance. At the same time, you want to have also good grip, or both in dry as well as wet conditions. And at the same time, you also need to have good abrasion resistance for a good longer mileage. So all these things are conflicting. On one hand, when you try to maximize one aspect, the other gets affected. And this is something that every tire engineers, either a compounding engineer or the tire designer, try to balance these things. And materials play a crucial role in helping the engineers and the designers to balance these things by the interplay of these materials. From let's say from our point of view, let's say from a fiber manufacturer point of view, when you look at tires in the tire design, they play a role in the handling behavior of the tire, because our materials offer extreme stiffness, and which can help in having a good handling behavior. Because of the material has very high strength, it also offers lightweight characteristics to the tire. So when the tire engineer is looking for introducing or reducing weight in the tire, they look at materials like our materials to incorporate that in the design.
The key common denominator is engineering. And when you engineer, you can build really great things. Martijn, looking back on the race and the partnership, what were some of your key takeaways?
I would say it's quite a challenge. It's quite an ambitious challenge that you put yourself in front of in the beginning of the year. So one of my biggest takeaways, I would say, is that you have to be able to dream big, try new ideas, come up with new ideas. We were very open-minded to what everyone had to say. And also, you have to be resilient. During our year, we had quite some setbacks. One of which was that during our testing phase, the car flipped over during a wind tunnel test in Germany. And I wasn't there when it happened, but when I got the news, I was just tons of questions going through my mind. What happened? Is the car still okay? can we still participate in the race? Eventually, everything went quite well, and we fixed everything. But as our team coach says, you can be sad, that's okay. Let's be sad for 15 minutes and then pick yourself up and continue and fix the issue at hand. You just need to go and keep pushing until you're over the finish. And then, that's one of the most important things I've learned.
Tony, when you dream big things happen. What were some of your key takeaways from the partnership and the race?
I think this is a special collaboration between three parties. Let's put it this way: two bigger organizations, Teijin Aramid, Bridgestone, and a student team. And I think there are not many cases that you have such kind of examples of cooperations and student team working together. And for us, this is, first of all, this was a platform to test our innovations or the new product, that is, to get a valuable feedback from the application. And secondly, another important thing, what I consider, is to bring the awareness of material, our materials in general, but also other materials, and the performance aspects, and now connecting that to the sustainability thinking. I think that is an important message that we can connect that to the younger engineers, which probably who all will be, future officials in the bigger organizations from tomorrow onwards, probably. So I think to carry on this message, that's also a good achievement from this collaboration.
Indeed, it was a special collaboration because the Brunel Solar Team won. So what you did worked. You won. Martin, the goal was achieved. Gentlemen, this has been a fascinating conversation. As we look to wrap up today, what's that one key thing you want them to take away with them today? Martin, let's start with you. Is it win? You always want to win? What is it, sir?
I mean, you have to have a clear goal and try to work as hard as possible to get there. And be persistent. Even when you have setbacks, keep on pushing. Try to dream big and listen to each other and try to come up with the best possible solution.
I like that. Tony, what's the one thing you like the audience to take away with them today?
I think the key to the main message is that sustainability and performance can go hand in hand when you choose the right materials and the right design. I think that is what we have proven in this collaboration. So that is the main takeaway or key takeaway for us.
So this engineering makes the world go round. When you get great teams together, you can build really great products. Today is tomorrow. Tomorrow's today. The future is solar racing. Tony, Martin, thank you so much for coming on SAE Tomorrow Today.
Thank you.
Yeah, thank you for having us.
Thank you for listening to SAE Tomorrow Today. If you've enjoyed this episode and would like to hear more, please kindly rate, review, and let us know what topics you'd like for us to explore next. Be sure to join us next week for another episode of SAE Tomorrow Today Unplugged, where I'll share my thoughts and insights into markets and the future of mobility.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.